if you needed an outboard rendering box for your Cloud Ray or Cloud PDM externals, or Cloud API, or Cloud models, Cloud is, if you've never seen this app,
persistent division.
It's rendering is a very similar parallel. You can just keep adding client nodes and just keep getting at arithmetically better performance out of rendering. So outboard boxes like that, which there are a couple of manufacturers now. I'll remember the name now. I believe it's called Redstone. Redstone.com.
Redstone.
Redstone. Yeah. And they've got the name of their app that you can log in and do all your remote admin to motherboards that don't have video cards on them. It's called Houston, and that's a free Linux package. And then I'll pull up their website. They've got a couple other things they do on their website.
What's the difference between blade computers and the single board computers?
This one, you have to come up with your own solution to deal with multiple SPCs on PCI. This one, like that one, has it's called the tower control. There's a single layer of abstraction to talk to you with layers. You can talk to a I can tell you that a skilled Beowulf operating system uses this function too. There's a single IP address, there's a cluster IP address. So any action you perform on that IP address gets distributed to all the IP addresses. You can ping it. This thing will come back and it'll tell you if there's any disk, cluster nodes, and the interface for the RLX machine do the same thing. You have a single layer of abstraction, a single system.
That HPC solution you're showing right there, that reminds me a lot of something that you showed in your lab before. It was something you were getting to price watch. And I'm not sure if that ever worked out for you. That's what my question is. Did that work out for you? You were able to put a dual motherboard, a dual proc motherboard in the front, a single proc motherboard in the back, and some hard drives in each pull-out. And then you were able to stack these. I'm not sure how many you said per room.
Oh yeah. Okay. Well, so one of my particular research interests is just this cluster. It looks like this lab that we have our Beowulf cluster at is going to take over the diskless Debian package management, and it needs a little bit of work right now. There's diskless packages of Red Hat is actually quite mature. There's a lot of labs out there that are running all of their client nodes diskless. You turn them on, they either, the way Skilled does it, and by the way, Skilled was like one of the last words left that people haven't co-opted from the original Beowulf method. It's on the Angular website, Skilled.com. The way you add a node to a Skilled cluster is you turn it on and you throw one of these floppies in it that you made off your head node called Beowulf. And it just sits there in ARCs. And your head node whacks the MAC address, sticks it on the DHCP server. Next time the thing reboots, it'll pixie boot, it'll get ether boot, it'll boot disklessly. Across the network. Now, most of your motherboards are coming with this in the LAN now. Excuse me, in the BIOS. Boot from LAN. A lot of motherboards have an EE Pro right on them. It's easy to put a machine like that into a cluster. And they don't all have those set as a default tag. But you can take, you can get a Linux boot disk and put the NVRAM settings in, and you boot from that, and it'll tell you to boot from that. There's quite a few of the diskless clusters you can do completely blind now. You put your NVRAM flash in, and then you put your DO boot thing in, or the other way around. DO boot will ARC, and I guess Kickstarter will ARC too, right? Is that
Kickstart will ARC as well, and you can it'll DHCP for its hosting IP and so on.
Okay.
I haven't done it in a long time, but I think it does it.
Do you need to run a separate DHCP server, or can you just run DHCPD as part of like the head node or something like that?
All the clusters I've seen, because they want everything to come out in the numerical order, they run one of the ISC 3.0 DHCP service, so that you know what node gets what IP address, and then so that it's not a free for all. That way way you can just look at the flashing red lights. Because like I say, these distance clusters don't have anything in it. Well, they've got floppies, but they don't have video cards. These are ridiculously cheap client nodes from Watson.
Just wondering how that would apply to, like, let's say, the Linux terminal server project where you can statically assign IP. Now, would you still be able to statically assign one IP for that one cluster? Or would you have to have, let's say, just an internal DHCP server where you can statically assign numbers out of this go based on that address?
Well, in fact, if you go to ltsp.org, they have a little script there. So what he's talking about is the Linux Terminal Server Project, which is, they're at the forefront of the distance clusters houses. There's a script that after the thing arcs and after you grab the MAC address, it will append a record to the bottom of the DHCPD.com. Now, generally speaking, everyone's using private IP addresses, 10.0, whatever, and they're using RSH. Security is absolutely a non-issue on a private cluster. In fact, so most distance clusters get their kernel from TFTP, which is pretty security itself. So if you're working from that level of understanding, and that your cluster, your wildly insecure cluster is behind a firewall or a locked door, then this is a pretty good solution. And I think you can get the scripts for building your turn on all your client nodes and then go to your .com.
And that's all at ltsp.org?
Yeah, these are the ones that have the, it's got a strange name. The actual name of the how-to, I think, is boot.html or something. Yeah, it's an awkward URL. But my first distance cluster, I followed this recipe to the letter and it worked right on the box. It's a very well written how-to. We can pull it up. Okay. Moore's law is really making clustering happen. I used to have a sample here, the one I can sample, it's not working. So, the only things I wanted to talk about that aren't Moore's law related are the Blue Gene project with IBM. They're not big believers in balanced clustering. They unbalance it based upon their particular needs. The Blue Gene project is now that we understand 40% improvement per year. Well, something standard, die size, price, whatever, and you're going to have a 40% performance. Well, you'll notice since the release of Penny and Hill, this curve has actually gotten to more like 60%. Well, up here. By 2001 is the Titanium, over 300 million gates and 130 watts. Dry ice on it. Nobody's clustering Titaniums yet. So, because clustering takes advantage of Moore's law phenomena in CPUs, RAM, hard drive performance, the whole 9 yards. Clustering is like Moore's law on steroids. Especially in recent, this scale is 94, and then you have to crush it down by a factor of 10, and you have to crush it down by another factor of 10 to show what's going on since the start of the strategic computer initiative. So, like I say, all the ASCIIs are in the single teraflops. These graphs, by the way, are from Jack Darngara, who's one of the writers of the MPIC book, among others, runs the top500.org. He also has a subset called topclusters.org, so if you want to see where your cluster rates, amongst others, in many categories, very subdivided by database issues. So these are the single digits of teraflop. And up here is the simulator, that means 43 teraflop. And so the next year or so, we're going to see probably yet another exponential jump in performance of the big guys. Now, there's the big guys, and then there's everybody else. The top 10, to embark on lots of stats on this, the top 10 machines make over 50% of the processing power of the top 500. Okay, so here, this slide's kind of long, but wanted to demonstrate how every Moore's law generation on the subcomponents that you use in building a client, we've all been moving pretty much in lockstep, except for one, which is network speeds, modem speeds. Turns out the alpha, lots of people cluster alphas. This goes way back, and the Alpha Linux project is quite mature on their clustering packages. The alpha is alive and well. So to calculate, if you wanted to go in and put your machine at Exodus, they would give you a 20-amp circuit and they'd say, hey, you get this whole stack, this whole 66U 19-inch rack, but you'll never fill that up with iTunes and be able to run on a 20-amp circuit. So Blade people saw this as a market where they could sell you low-power devices and you'd be able to run your enterprise server at Exodus, fill up the whole rack with 20 amps. Well, that doesn't apply to academia, which is where most of the data is. It doesn't apply to Department of Energy facilities and government agencies either, because electricity is in the overhead, and electricity, the amount of electricity you use even on 64, like I say, if you've got 64 nodes that are running, let's say conservatively 250 watts. So all the Athlon machines say you need a 300 watt power supply. Then you're generating 33,000 BTUs per hour. So you need a specialized piece of AC for that, or lots of fans and all that over windows. So it runs the heat. The cost of removing the heat rapidly becomes a priority rather than an afterthought. Power use is exactly a priority, but not in many of the traditional super or scientific clusters. Okay, so we use Debian. I haven't tried Midori Linux yet. I would assume Midori Linux the RLX boxes ship with either Red Hat or Windows 2000. They don't ship with Midori Linux. But they did experiment once with Debian 2, so the potato. Generally speaking, if you've only got 48 nodes, you're working at a command prompt. All of our scripts are basically just single line RSHs that we multiplied for the number of nodes we have. Now, that's a somewhat Byzantine way of doing it, I guess. If you're using skills, you don't have to do that. You can form a command on a single IP address, and you'll still get the same amount of data back. If one of them doesn't ping back, you'll know which one. It'll tell you what. But most, I have to say, most of your sysadmins that do, 48, 64 node clusters do everything at the command line. They usually do the scripts. The other good thing about skill, they have replacements for everything. They have BPSH, which is a replacement for SSH and RSH. This has slightly less data, so we do a lot of shell scripting. This won't be as much of a performance service. There's been a fairly large thread going on the Debian Beowulf list, Debian-Beowulf, about the overhead associated with running things in RSH. There's also, Debian also has something called DSH, distributed shell. I haven't tried this one yet. vproc is another thing from Skill's Beowulf operating system. If you start noticing performance problems, there's probably someone who's already investigated this and grab utility. So